Cross-site scripting is one of the most common attack vectors today. Studies have found that well over half of all websites have cross-site scripting vulnerabilities. According to White Hat Security, it's by far the most prevalent security flaw on modern websites. It's definitely something to be concerned about. OWASP has a cross-site scripting definition. Quote, cross-site scripting flaws occur whenever an application takes untrusted data and sends it to a web browser without proper validation and escaping. Cross-site scripting allows attackers to execute scripts in the victim's browser, which can hijack user sessions, deface websites, or redirect the user to malicious sites. End quote. This is a serious, non-theoretical vulnerability that's all too common on websites. A recurring theme through all the vulnerabilities that I'm going to be talking about is untrusted user data, which is key to a successful cross-site scripting attack, with a dependency on the victim's browser, as you'll see. There are numerous attack vectors for cross-site scripting, including in data that you might have stored within a site's database. The most important element of a cross-site scripting attack is when you expect a piece of data to be just that, passive data. But it is, in fact, some kind of functional payload that causes something to occur on the server, either immediately or in some deferred way, such as when the data is displayed in a web page. In this kind of attack, as the name suggests, the malicious data is scripting code that performs one or more things on your website. The effect can be visual, by adding or hiding page elements, or it can be truly malicious. The root cause of cross-site scripting attacks is the failure to validate user input data. The attacks usually happen when the attacker is able to trick the user into viewing hacked pages that look similar to your page, or maybe even uses hacked URLs embedded in spam emails. By the way, please, 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 don't click links in spam, even if you really want that miracle body modification product. It just encourages spammers and makes it a viable attack vector. All right, so let's talk about preventing cross-site scripting attacks. But first, a little bit about my demo woes. Here's the point in the course where I'd show you a demo of a few different cross-site scripting attacks successfully executing all manner of script in unintended places. All designed, of course, to shock you, I say, into action to make absolute sure that your applications are fully protected against the threat. But a funny thing happened on the way to some good demos. I just couldn't get any to work. Oh, sure, there are some complicated esoteric scenarios where you can make cross-site scripting work in MVC4. But I found that to create some simple demos that I could show you in a video with code that takes less than an entire course to explain, very little of which has anything to do with cross-site scripting but just sets everything up. But that meant that I had to explicitly turn off some or all of MVC4's protections against cross-site scripting, which started seeming just a little bit silly. I'd show you a successful attack, then we'd look at the code, and I'd have to say, now to get this to work, and by the way, you should never do this in production applications, but to get this to work, I had to turn off request validation, or make it okay to save embedded HTML and scripting through the field of a model, or do something else equally, well, stupid. To tell you the truth, this is the common things that books and articles, including some from Microsoft, have to do to demonstrate cross-site scripting. I realize that you need to understand the attack and what MVC does for you, but the approach of teaching you what you should never do seems pretty backward to me. There are certainly times when you need to do some of those things. Turn various features off in order to enable things within your web application. But at that point, you're running with scissors, and you'd better know what you're doing. In the case of cross-site scripting, that means thoroughly sanitizing all user input. There's no attack where that's more important. Now, this most certainly doesn't mean that MVC4 is immune to cross-site scripting attacks. But it's pretty darn close, particularly when the applications run in modern browsers. At least, I haven't been able to come up with some good examples that MVC doesn't block. But I don't want you to get complacent and think just because you're using MVC4 that you're protected. Remember, attackers are constantly coming up with new and better ways of attacking your websites, and cross-site scripting is still a viable tool. So, what are these protections in MVC4 that do such a good job? There are a few, which I'll cover now. But this puts me in the rather awkward position of telling you how to circumvent protections instead of how to implement them. So keep in mind that doing these things is not a good idea. All right, so the first one is request validation. You get this automatically for free on all action methods in an MVC controller. What this does is when it receives a request with data, ASP.NET examines it to look for HTML markup or script submitted within the request, whether it's in query string parameters, form fields, HTTP headers, cookies, anywhere. If it finds suspicious content, ASP.NET rejects the request by throwing an exception that you should catch. Now, you can turn off request validation by adding the validate input false attribute to any action methods or to a controller to apply to all its action methods. This sounds like something you might sometimes do when you have an action method where you need to accept input that contains embedded HTML. And that does happen. Not often, but it happens. Just be aware that you're then taking full responsibility for validating and sanitizing the input that you get. And do that. You've got to do that checking and validating. But, yes, I'm afraid there's a but. Adding validate input false isn't enough. MVC4 prevents this from having any effect unless you set for your entire application a setting in web.config that reverts to MVC 2.0 request validation, which is nowhere near as robust as what you get in MVC4. To use this, you just add the request validation mode attribute with a value of 2.0 to the HTTP runtime element. So just to allow unsafe input for a single action method, you have to dumb down request validation for the entire web application. I'm really sure Microsoft had some good reasons for doing things this way, but it just boggles my mind. Okay, you can also allow embedded HTML in a model field value using allow HTML. You can also allow embedded HTML in a model field using allow HTML, which does seem to work. In fact, this seems to be the only viable option for working with unvalidated request data, and it requires that you be using a model for the particular data. And it gives you a much more granular option. Rather than using a meat axe that affects all the data through an action method, this limits the damage to individual fields on the model. But again, keep in mind that you have to be fully responsible for validating and sanitizing the data. And how you do that depends on the data and how you're using it. So there's a lot of ways to do that. There's another option that you can try as well, using the request.unvalidated helper method, which is part of something called deferred validation. This lets you access unvalidated data that comes in as part of a request, whether by query string parameters, HTTP headers, form fields, whatever. But for this, you also need to change the request validation mode within web.config. To turn on deferred validation, add request validation mode equals 4.5, not 2.0, but 4.5, to the HTTP runtime element. But this option seems to be flaky and fragile, as some of the other options are. Frankly, request validation is kind of a mess in MVC4. You get strong protection, that's good, so by default you get strong protection. And it's almost impossible to circumvent, even in well-structured, well-defined ways. Some applications have to work with risky data, and MVC4 doesn't make that very easy. Not that it should be, but it shouldn't be this hard. The moral of the story? Don't try to turn off request validation. You'll spend way too much time getting it to work right, and you won't be happy when your application is successfully attacked. Hopefully, it'll be something Microsoft will clean up in the next version of MVC. And the really good news is that modern versions of the major browsers are starting to provide protections against cross-site scripting. This isn't sufficient alone, but the more components of the web browsing experience that are building in protections, the safer we'll be. All right, other options for preventing cross-site scripting attacks. One is HTML encoding. This transforms text from HTML that is interpreted by the browser and rendered to a form that the browser renders as plain text. So instead of script being parsed and executed, it just displays as plain text, which makes the page look pretty ugly, but at least then you're preventing a cross-site scripting attack. The good news is that the Razor View engine HTML encodes text by default. You don't have to do a thing differently to get this rather big benefit. If you're using the Web Forms engine, just add a colon instead of an equal sign within the brackets, like that. But if you really need or want to, you can circumvent encoding with the raw HTML helper method. And that's within the Razor View engine. This causes the text to be treated as HTML rather than text that should be encoded. This is one of the cross-site scripting circumventions that I would have had to do to make a cross-site scripting demo work. But it is a useful technique if you need to display validated and sanitized data that can include HTML markup and script. This is often the case in a CMS application, or content management system. But it's not something that you should need to do very often. Just let MVC encode everything, period. Okay, so the bottom line for preventing cross-site scripting attacks. Never trust user input. Hopefully you're getting a theme here, a recurring theme. Don't trust it when it comes into the application, however that happens. And certainly don't trust it when you render it on a page, which is where HTML encoding comes into play. Now, another protection that's built into ASP.NET is the anti-cross-site scripting library. This library has long been a useful tool for preventing various kinds of script injection attacks using ASP.NET websites. Anti-cross-site scripting is part of the Web Protection Library, along with a security runtime engine. The security runtime engine is an HTTP module that can automatically encode almost all at-risk output. For the most part, this means that any output that's generated from untrusted user input is encoded. Microsoft had released these tools under its very liberal Microsoft public license that lets you do anything that you want to with the library. The library consists of an assembly with a set of encoding functions for any kind of user input, including HTML elements and attributes, XML, CSS, LDAP, and JavaScript. It uses a whitelist, which causes the library to encode anything not included in the whitelist. It's designed as a protection against cross-site scripting attacks, as the name implies. So the library helps you practice one of the fundamental tenets of web security. Treat all user input as dangerous and toxic threats. Now, the big news is that Microsoft has incorporated the core anti-cross-site scripting library features into version 4.5 of the .NET framework. And they put it in the system.web.security.anti-XSS namespace, which is exposed through an anti-XSS encoder object. You can use methods of that type to encode data in various ways. But the easiest way to use the library is to configure an ASP.NET application to use the anti-cross-site scripting features by default, replacing the default encoding features, including those in MVC. You can do this by adding the encoder type attribute to the HTTP runtime element in web.config like this. So you just need to add this code in addition to any other attributes of the HTTP runtime element. So there's a number of features that Microsoft incorporated from the library, support for a variety of encodings. One is data for use on web pages. And this includes HTML encode, HTML form URL encode, and HTML attribute encode. And then there are methods that encode XML data, including XML encode and XML attribute encode. And then there's some methods that encode URL content, including query string parameters. And those include URL encode and URL path encode. And then there's a CSS encode method that encodes input strings used in CSS or cascading style sheets element values. And the library also performs JavaScript encoding, which is yet another form of a cross-site scripting attack. The current library namespace, if you use the standalone library, is Microsoft.security.application. So if you use the library today, you'll need to update code to use the new system.web.security.anti-XSS namespace. Because it's part of the .NET framework, you won't have to worry about deploying the library DLL to an application. One less detail to worry about.